Welcome to Team G503. I am your host, Scott Schiller, and in this video, I'll be disassembling a 1942 Ford GPW L134 engine. Basically, what I'm going to be doing is just removing all the components of the engine down to the bare block so I can take it to the machine shop and it can be rebuilt. The thermostat housing is held in place by three 3/8 by 16 pitch by 1 1/8 bolts. I'll remove all three of these with a socket and a ratchet. Prior to disassembly, I've soaked all the bolts down with a penetrating catalyst. This will allow for easy removal. I'll simply break the first course of threads and then remove the following threads by hand. The thermostat housing is part number A1192. As I remove the last bolt, I'll be able to simply push my hand against this thermostat housing, and inside I've got a little surprise here. It's a piece of PVC. That should be the thermostat retainer, part number 639651, which will be made out of metal. This is an interesting little find. And inside here we've got the thermostat, number 637646. There's no cracks that are visible, and it appears we can reuse this. If you look closely, it's marked GPW 8250 with Henry Ford's F script on it. Next, I'll be removing the water pump. The water pump is held in place by three 5/16 by 18 by 7/8 inch bolts and one long 5/16 by 18 by 2.5 inch bolt. Simply using a socket and a ratchet to remove the top bolt. The top bolt is one of the 7/8 inch sizes and it has a lock washer. The next bolt I'll remove is the one next to the outlet, and that one is the long one, the 2.5 inch long bolt, 5/16 by 18 by 2.5 inch. Moving to the opposite side of the outlet, I'll remove that bolt. These bolts are coming out very nicely and cleanly, and they're in really good shape. I'll move to the bottom here and pull this one away. I'll be tagging and bagging all these to be cleaned up in the future, and we'll reuse them when we do the build. Using a soft rubber mallet, I'm striking the water pump to remove it from the block. Give it a couple nice blows. It'll break away free and clean. Water pump is number 649844, and I've used nothing to pry against or score the block. This is an earlier GPW engine by Ford, and the head is held on by a series of head bolts that are 7/16 by 14 by 2 3/4 and head studs that are 7/16 by 14 by 3 7/16 by 17 by 20. I'll start by removing the nuts off the top of the studs. There's been some great debate whether or not head bolts and head studs can be reused, as does the metal get stretched and damaged as you tighten them and torque them. But as I remove this head bolt, it's obvious here, and I'll bring it to the camera, you can see it. This is an original F-script Ford head bolt. The crossover tube has been broken away from the bracket, but it's held to the top of the head with a head bolt, so we'll remove that, and I have the tube and I can repair that in the future. My next step is to remove the 4 spark plugs from the top of the head. I'm just using a simple ratchet with a spark plug remover. It's got a rubber end inside. The spark plugs are part number A538, and we're looking at this one. You can see a little oil on it. The GPW engine was probably burning a little oil. Just go ahead and remove all these. We're not going to be reusing them. With all the head bolts and the stud nuts removed, I'll take my rubber mallet and I'll just go ahead and tap the corners of the head just a little bit to see if I can't get the head gasket to break away nice and clean, make it easier for me to remove the head. To remove the head, I've cut myself some simple wood shims out of some 1-inch stock that I had laying around, and I've cut an angle. And what I'm going to do is at each corner of the head, I'm just going to tap a little bit, maybe 1/8 to 1/16 of an inch, just lift the head up on the studs. This goes back to the reason, do we save original fasteners or not? However, you might want to replace just the head gasket, and this could really help you without pulling your studs off and damaging the threads with a remover. I've cut enough shims where I can continue to raise the head by adding another shim into the one that I've already placed by setting it on top like I'm doing here. You can do this with regular old household shims that you can buy at a big box store. It's not a big deal. The wood's not going to damage the block. I'll keep adding shims on top of each other until the head reaches the point where it's level with the top of the studs on the block. After I've got the head almost level, I'll reach on the sides and wiggle it back and forth, being careful not to pinch my hands in between the head and the block, and I'll pull straight up and remove the head. Luckily for me, the head gasket came off clean with the head. The cylinder head is part number A1534. It's Ford marked, and I'll turn it over here, and I don't see any damage, so that's a good sign. The accelerator linkage and cross shaft and bracket are part number A1243. They're held in place by a pair of studs that are 1/4 by 20 by 2. To remove it, simply remove the 2 nuts, and remove the lock washers. I'll put these aside in the bag and mark them accelerator linkage bracket. With the nuts removed from the studs, simply grab a hold of the bracket and remove it from the block. There's still the remnants of the exhaust and intake manifold gasket that I removed in a previous video, and it's held in place by studs that are size 3/8 by 16 by inch and 15/16 by 3/8 by 24. To remove the studs, I'll be using my stud removal tool. It's really simple to use. All you do is you slide the one end, the nose, onto your stud, tighten down the little nut to get the teeth to actuate to the stud, and then simply take a wrench and crank the stud away from the block. These studs have been soaked with PB Blaster, so they should come out pretty easily. These are another one of the sets that are kind of difficult sometimes and like to seize inside the block, and there's all kind of methods to remove those, but I'm seeming to have good luck with these. I'll go ahead and remove all the studs. This stud removal tool works really well, as you can see here, and the studs are coming out really clean. Using the same stud remover as I did with the manifold and intake studs, I've still got some studs on the top of the block for the cylinder head. I'll use the tool in the same fashion, although this time I'm going to need a breaker bar to get the actual stud to break away. I've soaked these also in PB Blaster, so they should come out pretty easily. The head studs sometimes want to be really difficult, and I've seen all kinds of methods to extract them, including applying heat and using wax on the threads. These seem to be coming out pretty easily, so I've got these loose and I can spin the rest of the threads out by hand. I'll repeat the process on the remaining studs. The valve cover is held in place with two bolts, one through the vent down tube and one shorter one on the opposite side of the cover. The shorter bolt on the cover is size 5/16 by 18 by 3.0625. Note the copper crush washer. It seals the hole here in the valve cover and the bolt. I'll move to the opposite side of the vent, and the bolt that holds this in place is size 5/16 by 18 by 4.125. After I remove the longer bolt, I can grab a hold of the cup and I can remove the actual assembly for the vent, and inside there's a baffle and a gasket. The engine valve cover is part number 630303. The baffle is part number 630298. The gasket is number 630299. I'll remove the long bolt from the cup. It's in good shape, and you can see here it's F-marked. The next step in the process is to remove the intake and exhaust valves from the block. In order to complete this process, you will need a valve spring compressor. They are available online. This one is vintage, and you can find them on some of the auction sites. Insert the ears of the spring compressor on the boss on the tappet side and against the bottom of the spring where the retainer cap is. Turning the handle on the spring compressor, compress the spring until the retainer locks are just exposed. Using a magnet, you can remove the retainer locks from the bottom side of the valve. There are 2 retainer locks per valve that are fitted into a machined recess on the stem of the valve. With the valve spring compressor still in place, I can take my finger on the underneath side and push the valve up through the top side of the block and remove it. Here on the valve, you can see the area where it's recessed and machined to accept the retainer locks. Relieve the tension on the spring and remove the compression tool. I can now reach inside the block and remove the spring and the retainer cap. Repeating the same process for all 4 intake valves and all 4 exhaust valves, I have them all removed, and we can look inside and we can get a good look at the tappets. The oil pump is held onto the block with 3 studs, size 5/16 by 18 by 2 3/4 by 5/16 by 24. This pump is marked F GPW 6616. Begin removing the nuts on all 3 studs that go through the oil pump to the engine block. These fasteners are in great shape and I can probably clean them up and reuse them. Once all the nuts are removed from the studs, I can remove the oil pump. I'm going to be using my saw-faced rubber mallet once again and just tap the edges lightly. You don't have to strike this hard. As you tap around the edges, you'll notice that the oil pump starts to separate away from the block, and you can pull on the pump with some downward pressure with your opposite hand and then wiggle it off the studs. Continue to pull the oil pump away. The oil pump is a chain-driven pump number 637636. I'll remove the 3 studs for the oil pump with a stud remover. Once again, I didn't use anything to pry against the block and cause any damage to the face, and here's the 3 studs removed successfully. The oil filler tube, support bracket, and dipstick are press fit into the engine block. I should be able to wiggle this back and forth from the top and pulling upward be able to remove it quite easily. This one has got some sort of sealant around the base fit to the engine block. Putting steady pressure as I lift up, just wiggling it back and forth, Just be careful not to do any sudden movement as to pull this out and maybe damage something. The vented oil filler tube is part number A6915. The distributor assembly is part number A9075. To remove it, we'll have to release the bracket and grab a hold of this and remove it from the engine block. The bracket that holds the distributor in is actually called an advanced control arm assembly, and its part number is A1674. I'm using a wrench and a flathead screwdriver to remove the bolt or loosen it, and I'll take the screwdriver and just separate the advanced control arm assembly a little bit to give me some room to allow the distributor to come out. Removing the distributor is a problem area on the L134 engine. These have a tendency to get seized. I've soaked this in a penetrating catalyst for quite a while, so I'm easily able to turn it back and forth and remove it from the block. As you see here, I'm just going back and forth and pulling straight out until I get the shaft outside of the engine block. To remove the advanced control arm assembly, there's one bolt that's into the block, and I'll just remove the bolt and you'll be able to remove the whole assembly as one unit. Such a simple assembly, but absolutely crucial to the proper functioning of the L134 engine. In order to remove the timing cover, I'll have to remove the crankshaft nut and remove the pulley. The flywheel bolts on the back side of the engine are blocked with a piece of wood between the bolts and the engine stand so the engine can't turn. I'm using a 3/4 inch drive ratchet with an 1 3/8 socket to remove the crankshaft nut. The crankshaft nut is part number 387633. I'm using a simple 3-armed puller, medium-sized, and I've got it installed on the pulley where the ears of the puller are behind the backside lip of the pulley. I'll take a crescent wrench and I'll crank the inside bolt against the crankshaft very steadily and evenly, and it will pull the pulley off the end of the crankshaft. The puller makes it very easy to remove the pulley. Here I'm just twisting it off by my fingers. I'm almost to the end of the crankshaft. Off it comes, and the pulley is part number 645623. Note the slot on the pulley that is keyed into the Woodruff key on the crankshaft. I've turned the engine over on the stand so you can see the oil pan on the skid plate. And the oil pan is held into place with 20 5/16 by 18 by 11/16 bolts. Something interesting about these oil pan bolts, you have some ECs, some F marks, some recess, some not. It'd be interesting to know the history and how that happened and at what motor pool that happened at. On the front side of the oil pan, you'll notice the crankshaft pulley splash guard that I'll remove. I'm just using a simple hand crank with a socket and remove the bolts. The crankshaft splash shield is part number A1124, and we'll remove that. There should be some spacers in here, and there's not. The hand crank driver will make it really easy for me to remove these bolts very quickly and simply, and I'll just work my way around the pan and remove all the bolts. Once I have all the bolts removed, I'll grab a hold of the oil pan, and it's stuck pretty good with the gasket. So I'll go ahead and I'll take my old faithful rubber soft face mallet and simply tap around the outside edges and break the seal on the gasket to the block. The oil pan is part number A7238. The gasket seal is now broken, so I can simply lift the oil pan up and remove it from the block. With the oil pan removed, we can get a great look at the internal working components of the engine, such as the crankshaft and the caps and our connecting rods and our oil float pickup. Before I remove any of these components, I'll flip the engine right side up onto the engine stand, and I'll have to remove the cover and the timing gears and chains and some other things before I can get inside and remove these components. The bottom of the timing cover is fastened through the oil pan, that's why I had to remove that first, and it's also fastened to the block with a series of studs and a few nuts and bolts. I'll start by removing the bolt and the nut that go through the actual engine mounting plate. Note the one bolt that holds a bracket that holds part of the fuel line at the top here of the cover. I'll remove that and the rest of the nuts that are on the studs. The timing cover for the chain drive is part number A1190, and I'll simply pull it away from the studs. Inside looks really clean. Note the stud on the cover that rides against the camshaft plunger. The chain rides on a sprocket that's on the camshaft and a lower sprocket that's on the crankshaft. The lower sprocket on the crankshaft is covered by an oil slinger, as we see here. The next step is to remove the chain drive components. To remove the Woodruff key and the slinger, a brass drift can be placed on the front side of the Woodruff key and tap it gently with a hammer until the Woodruff key is removed from the crankshaft. The Woodruff key is part number 50917. Slide the oil slinger off the front side of the crankshaft. It's part number 375877. The lock tab ears that hold the upper sprocket into place on the camshaft will have to be tapped back with a brass drift to enable the bolts to be removed. Repeat the process on all 4 lock tabs. Proceed to removing all 4 of the upper sprocket bolts. I'll continue removing the bolt and show you the camshaft gear lock tab number 315932. There's 4 of these. The lock tabs keep the bolts from being able to vibrate out and hold in place the camshaft gear upper sprocket, part number 638458. Remove the upper gear from the camshaft and remove the timing chain from the lower gear on the crankshaft. The standard timing chain is part number 638457. I'll remove the timing cover gasket from the engine bracket. The timing cover gasket is part number 630365. Remove the 3 bolts that surround the camshaft, and then we can remove the 2 nuts on the studs that are on the outside of the lower part of the engine block. On the L134 chain-driven engine, the engine mounting plate actually acts as a support or a bracket to hold in the camshaft to the block of the motor. Remove the engine mounting plate from the block off the studs. You flip it over and you'll notice this gasket here that goes between the block and the actual engine mounting plate. The camshaft plunger is part number 375907. I'm using a magnetic screwdriver here, not to push or pry anything or twist anything, only because it fits inside the hole here on the camshaft, and I'll pull out the camshaft plunger spring. The cam plunger spring is part number 375908. The oil float is held into place with 2 bolts to the block. As you can see here, they're safety wired, so that safety wire will have to be cut and removed before we can remove the float. I'll simply take a pair of wire cutters and cut the wire and carefully remove it. The safety wire is used so the bolts don't vibrate loose and wind up in the oil pan. This could cause severe internal engine damage. The 2 mounting bolts of the block can now be removed, and you can see here the hole that's inside where the safety wire goes through. That's how it's wired in. I can now remove the float from the block. This will have to be disassembled and thoroughly cleaned before reuse. Remove the PAL nut with a socket or a boxed end open end wrench. The PAL nuts are part number 52825. Once both of the PAL nuts are removed, we can move forward and we can remove the actual nut that holds on the rod cap. Once I get the nuts loose, I'm only going to remove them to about the halfway point on the threads of the nut. Once I have both of the nuts removed to about the halfway point on the threads, I'm going to take my soft face rubber mallet and simply tap the top of the nuts so I can remove the cap from the actual connecting rod. Continue by removing the 2 nuts from the bolts on the connecting rod. Remove the connecting rod cap by lifting upward. Once the cap is removed, we can see here the connecting rod bearing. The connecting rod bearing set is part number A7233, and they are available from standard to 60 oversizes, and it would depend on what was done to your crankshaft to determine what bearing you would need. Before I remove the piston assembly from the block, I'll take a little piece of hose and apply it to each bolt on the connecting rod. This is just a precaution to prevent any scoring to the inside of the cylinder wall as I remove the piston assembly. Pushing down on the connecting rod with my thumbs just to get it started into the cylinder wall, and you can see the hose also protected the crankshaft. Using a wooden handle of a hammer, I'm tapping the piston assembly outside the block. I'm guiding the connecting rod inside the cylinder wall and pulling out on the piston head to remove the connecting rod and piston assembly. After I remove each piston assembly, I'll replace the cap back onto the connecting rod in the exact way that I removed it. The caps are machined to only fit on one way on the connecting rod. I'll replace the original hardware back, and these will have to go to the machinist with me to be examined, checked, and possibly resized. Stamped on the face of each piston, you will find a number, and that designates the area in which cylinder to which it belongs. Proceed to the next piston assembly and remove it in the same manner we did the first. I have the crankshaft positioned so that the number 4 and the number 1 piston were at their lowest points in the cylinder walls. In order for me to easily remove the number 2 and 3 pistons, I will turn the crankshaft until the number 2 and number 3 pistons are in their lowest location in the cylinder walls. I will now have easy access to the PAL nuts and the bolts on the connecting rods, and I can remove the number 2 and number 3 piston assemblies. The L134 engine has 3 main bearing caps: the front, the center, and the rear. I'll begin by removing the center main bearing cap, which is held in place like the rest of the bearing caps with 2 large bolts. I'm using a 1/2-inch drive breaker bar to break free the bolts and spin them free. The main bearing cap bolts are 1/2 inch by 13 by 2 3/8. After I remove the second bolt, I will put them back into the cap that I removed in the same place of which I removed them. Remove the cap from the engine block, and inside you will find a main bearing. The main bearing set is part number A6798. Moving to the front side of the engine, we'll remove the front main bearing cap in the same way we did the center. Once the bolts are removed, the front cap can be removed, and again, I will put the bolts back into the same locations that they came out of. Remove the bolts from the rear main bearing cap. The rear main bearing cap is probably the most difficult of all 3 to remove. With some effort, you can get this out. You may have to use a brass drift or a soft face hammer to tap it loose. A lot of times sealants are used and it makes it difficult to remove the cap. With the rear cap removed, we can see the seals, including the rubber dowel seal that goes from the side of the cap to the block. And inside, you can see that we've got the original style rope seal. Today they make modern rubber reproduction ones that work fantastic too. Before removing the crankshaft from the block, I'll remove the lower sprocket using a 3-jawed puller and just apply some pressure to the front of the crankshaft and the sprocket will come off. Turning steadily on the puller, a few turns, and the sprocket will come off the front side of the crankshaft. As I remove it, you can see a Woodruff key here, and that's keyed in to the sprocket here. I'm using a brass drift and a small hammer to tap away the Woodruff key that's inserted on the front end of the crankshaft. You simply take your drift, start the front, and tap gently until the Woodruff key comes out of the slot in the crankshaft. With the Woodruff key removed, you can now remove the spacer, the thrust washer, and any shims that may be present. As here, if any shims are present, they will be on the back side of the thrust washer. With all the caps removed, I can grab the front side and the back side of the crankshaft and remove it from the block. With the crankshaft removed, I can remove the rest of the bearings from the block. Usually the bearings will come off their seats pretty easily, but here I just need to tap it with my brass drift and I can pull it off the pin. And there you have the bearing. They're all removed. The next step is to remove the camshaft. The camshaft rides on 4 cast locations in the block. When removing the camshaft, be careful not to damage any of these areas with the lobes of the camshaft. I'm using my brass drift and my soft face mallet to just get the camshaft started. I'll remove the thrust washer from the front of the block. As you can see, the camshaft is starting to come out the side of the front of the engine. I'll tap a little bit and just get it started, and then I can do the rest by hand. I'll now work inside the block and remove the camshaft, being careful not to damage any of the lobes and working it through the holes in the castings. With one hand outside and one hand inside, I can work the camshaft out of the front side of the block past the bearing. With the camshaft removed, we can see the tappets, and I'm going to call them number 1 through number 8, front to back side of the engine, and I've put together myself a little piece of cardboard with just numbers 1 through 8 and made holes in it to fit the size of the tappets, and made myself a note that tappet 1 starts at the front and continues to the back. Simply reach inside the engine and pull upward on the tappet and it will come out. I then will take the tappet and I will place it inside the cardboard into the respective number of which I removed it. The tappets are very hard steel and can probably be reused in the rebuild of the engine. However, I would only do so after the machinist has checked them that they have the proper convex face that contacts with the lobes on the camshaft. I also like to put them back into the same location in the engine block of which they came. The studs on the face of the block will have to be removed. I'll do so using my stud removal tool that I've used previously in this video. The timing cover mounting studs are part number 384958. On the front and rear side of the block, there are these oil galley plugs that will need to be removed for the oil galley to be cleaned. There is a 3/8" square bit tool to remove this oil galley plug. I'm going old school and in honor of my grandfather, use a punch that he gave me a long time ago to remove the actual plug. I'll just simply insert it and use a crescent wrench to turn it out. The punch fits just fine and won't damage the plug in any way. With the plug removed, I'll repeat the process on the back side of the engine. The GPW L134 engine is now stripped and ready to go to the machine shop. Thank you for watching. I hope you found the video informative and helpful, and you can do the same thing and have your engine rebuilt, rebuild it yourself. I'll be taking the block and the other components to the machinist where you can check for tolerances and specs. I'm pretty sure that that engine's going to have to be sleeved because it's been rebuilt twice that I know of. There's a tag on the outside that stated it was done 30 over at one point, but when I actually pulled the engine apart, as you see, there was a 60 over pistons that has been done. So that would lead me to believe that this has been rebuilt twice. There was a couple of things also that I did not take off on that block. The 2 pipe thread plugs and the oil passages. Those were all chewed up and burred up, so I'm going to let the machinist take that off just because I don't want to hurt those journals on that GPW engine. And the other thing that I'm going to have them do is pull the camshaft bearing and replace it with brand new. If you'd like to see the other archive videos of the 1943 Willys Team G503 project, you can follow along and subscribe to us at Team G503 on YouTube. Until next time, keep it safe and happy Jeeping.